In this video, we're going to look at rational and irrational numbers. So first, a definition of what we mean by rational. Rational numbers are any numbers that can be written as a fraction, as an a over b, where a and b are both integers. So anything that can be written as, say, 2/3, -3/4, as long as we can write it as one number over another number where they're both integers, then that's going to be a rational number. Here are some examples, and the reasons these are all rational numbers is because we can write them as a fraction where the top and bottom are integers. So the 3.2, for example, we can write that one as 32 over 10. That would make it rational. Even the number 5, we could write it as 5 over 1. Again, still rational. The -3/4 is already rational. It's already being written as an integer over an integer. And the square root of 16, we can simplify that because 16 is a perfect square. So the square root of 16 is just 4, and we can write that as 4 over 1. So if you can write it as a fraction, then it's rational. And that would leave us with irrational numbers. Those are numbers that are not rational. So it's basically everything else. So their decimal form does not repeat and does not terminate. So some examples. The square root of 19. The square root of 19 is not a perfect square, so that's a decimal that goes on and on forever without repeating and without ending. So that would be irrational. And then also anything that has pi in it would be irrational, because pi is one of those irrational numbers that again goes on and on without terminating or repeating. So if you see a pi in an expression, you know that's going to be irrational. So we have some examples here, but this time we're being asked to circle the integers. So we're not looking at rational or irrational, just integers. And remember, integers are all of those numbers that we use to count, like 0, 1, 2, 3, and so on. And also their opposites, -1, -2, and so on. So the first one here, 7/15, that's a fraction. We cannot write that as an integer. The second one, 94.94, also that's a decimal. We can't write that as an integer. But the one after that, the -63 over 7, we can simplify that. And we can say that 63 divided by 7, that's 9, so that is -9. -9 is an integer. And then the 83. 83, that's a counting number, that's an integer. And -90, that's an integer. So in this example, we do have 3 integers here because they're not fractions or decimals. Even the one that looks like a fraction can be simplified to being an integer. And our next example, we're asked whether it is rational or irrational. The first one, -28/9, that is a decimal, and it does end, so that would be rational. Our next number is the square root of 29. The square root of 29 is not a perfect square, so we can't completely remove the square root, so that is going to be an irrational number. Then 35.78 with the line over it, meaning that those digits repeat. Repeating decimals are fine. Those are still rational. It's just when it goes on forever and doesn't repeat that it becomes irrational. So repeating decimals are rational. And then we have negative square root of 81. The square root may look like it's going to be irrational, but 81 is a perfect square, so we can simplify that to being -9, because the square root of 81 is 9, so that is rational. And our last one, -17 times pi. Anytime you see a pi, that's an indication you're going to have an irrational number. Take a moment and pause here for this example to see if you can label each one of these as being either rational or irrational. Now going through them, the first one, that is a decimal that terminates, so it ends. That is rational. The square root of 15. 15 is not a perfect square, so we're not going to be able to get rid of that square root. That's going to be irrational. 5.62 with the 62 repeating decimals are still rational. Square root of 36. Square root of 36, that does simplify. The square root of 36 is just 6, so that makes that one rational. And then the last one, 12 pi. Anytime you see a pi, that's an indication of an irrational number.